Okay, this is for section 2.3, and it's called rate of change and slope. Okay, rate of change and slope, and hopefully a good bit of this will be reviewed from your Algebra 1, okay? So I think you've seen most of this before. First thing the author does is it goes in and defines slope. Slope, and in math they use the letter lowercase m to represent slope. Slope is the rise over the run. That is what they consider the definition of slope. Slope is rise over the run. And if I give you two ordered pairs, and if I give you two ordered pairs, x sub 1, y sub 1, and x sub 2, y sub 2, and make sure you write those as subscripts, okay? Then if you have those two ordered pairs, it's y sub 2 minus y sub 1. That's the change in the rise. And the run is x sub 2 minus x sub 1. So that's the formula for figuring slope if they give you two ordered pairs. If you go on into higher level math, they will write that with the Greek letter delta, the triangle. This is to get you ready for the sororities and fraternities of America. Okay? And I actually had to look one up today. Caitlin Days posted, and I'm going, and it was delta gamma. So, yep. So this would be the change in y. The Greek letter, this is the Greek letter delta. And there are uppercase and lowercase letters in the Greek letter system. And when you get into trig, you'll get a lot more of those. And usually delta is read change in. So if delta y over delta x, it stands for the change in y over the change in x. And another way to say it is that is the rate of change. So really, the slope, when you're figuring the slope of something, you're figuring the rate at which that's changing. Okay. If we do it picture-wise, and let's say I have a line that comes through here, at any point on that line, because the slope should be the same all the way along that line, you can pick two ordered pairs on that line, and usually you want to pick two that are on the grid so that you can tell what they are, and you can draw a right triangle, and this would be considered the run, and this would be considered the rise. And if you labeled your 2 points, the x sub 1, y sub 1, and the x sub 2, y sub 2, the run, oh sorry, I labeled that wrong. This is the rise. Sorry, that's my fault. Thanks. Sometimes I say it right and write it wrong, or vice versa. Okay. Yeah, the run is left or right, and the rise is up or down. Okay. And you can draw that triangle above the line or below the line. So I could also draw the triangle over here. Okay. And that would work too. Okay. So let's go through and figure an example. Okay, say they ask you to find the slope of the line that passes through. Find the slope of the line that passes through the ordered pair 1, 3 and the ordered pair -2, -3. Find the slope of the line that passes through the point 1, 3 and -2, 3, -3. Okay, I'm going to do this both ways. So I'm going to label this one as my x sub 1, y sub 1. This one is my x sub 2, y sub 2. And you guys know, if I can do one thing for you, it's to get you to write a formula down, substitute in, simplify. So write the formula down. M equals, and it's always the rise on top. So the y's are on top, and it's in that order, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And now you just fill into the formula. So my y sub 2 would be -3, minus, my y sub 1 would be 3, my x sub 2 would be negative 2 minus, and my x sub 1 would be 1. Okay, so negative 3 minus 3, negative 6, negative 2 minus 1, negative 3, and negative divided by negative, positive. Okay, so that's one way to do it, is by the formula. Okay, now let's do it by the sketch. Okay, so draw a sketch. So 1, 3, and then negative 2, negative 3. Okay, and draw a line. Okay, and then you can draw the triangle. And I don't care if the triangle is above or below, but it should be a right triangle. Close. That's a right angle. And the difference, if you look between 1 and negative 2, this should be 3 spaces. And between negative 2 and, negative 3 and 3, this should be 6 spaces. And if you did just the delta y over delta x, or rise over run, be 6 over 3, which would reduce to 2. Okay. Plus, if you remember, anything that tilts in this direction has a positive slope. That will also help you as a final check. Okay? Okay on that one? Okay, so if you do it by the formula, like on a test, you could always check it by graphing it. If you did it by the graph, you could always check it by doing it by the formula. Okay, now I want you to look on in your books at page 76. And I want you to go down to the example down at the bottom of the page where it says number 1, recreation. Okay, everybody finding that? Okay, look at that. It says the graph at the right shows the number of gallons of water in the swimming pool as it's being filled. At what rate is the pool being filled? Okay, notice on the chart. Okay, they give you a graph. Okay, and this is time in minutes, and this is the water in gallons. Okay, and they've given you 2 points on that line. Okay, 2 ordered pairs are 3 and 108. 3 minutes, there's 108 gallons, and at 7 minutes, there's 252 gallons. Okay, so they want to know on that. It says at what rate is the pool being filled. So they want to know the number of gallons per minute. So what they're really asking you for the rate of change of that is the slope. So slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So label one of those. I'm going to label this one x sub 1, y sub 1. It does not matter which one you label, but one of them has to be x sub 1, y sub 1. Where people make an error is if they do it x sub 1, x sub 2. An ordered pair always has an x and a y. Okay, so then sub in. So I would have 252 minus 108, and I'd have 7 minus 3. You agree with that? Okay, and then if you simplify that, 252 minus 108, 144 over 4, and then reduce that. 4 goes into both of them. 36 over 1. So this is the rate at which that's changing is 36 gallons per minute. Is the rate at which the water's flowing into that pool. It would be interesting with the hurricanes that just happened in Texas and Florida. And when they were talking trillions of gallons of water, you know, the rate at which it's changing, you know, even if you said the rate at which it's, the height at which it's changing, you know, that would be probably amazing to look at the math involved. Okay, so when they talk rate of change, don't let that scare you off. Rate of change, they're just saying what's the slope. Okay, there's a couple special cases. Okay, and these you've had before. Two special cases. For slope. Okay. Okay. First, every horizontal line has zero slope. If you filled into the formula, your y's up at the top would be 0 divided by something. Okay, but every horizontal line. So if you have a horizontal line like that, it's going to have a slope of 0. The way I remember it, I always tell students to remember it, a horizontal line, think of the sun on the horizon. Horizontal line, 0 slope. Okay. The other special case is every vertical line. Yep, you can say it's undefined or no slope. No slope, or you could say undefined. Some authors say undefined. I always think like of a telephone pole, there's no slope. So if it's a vertical line straight up and down, it's no slope. Okay, or if you say it's undefined. Okay, and then if you look at the only choices, you only have really 4 choices for a line. If the line tilts anything in this direction, you know it's a positive slope. Okay, if a line tilts anything in this direction, it's a negative slope. So you can kind of check your answers. If you graphed a line like that and said it was a positive slope, you know that's wrong. Okay? And then our 2 special cases. Okay, if you have a horizontal line, 0 slope. And the last case would be a vertical line, no slope or undefined. I'll take either one of those. So vertical line would be no slope. Okay? And I'm thinking you've had all that in Algebra 1. Okay? Okay? Now let's look at another example. They will ask you to graph the line through, and they're going to give you an ordered pair. Graph the line through the ordered pair 1, -2, and parallel to x minus y equals -2. Okay, so first thing, you can sketch that ordered pair. It's got to go through 1, -2. It's got to go through that point. It's got to be parallel to this line. First thing I would do is figure out what is the slope of that line. Get it in slope-intercept form. Get y by itself. So I would probably add y and add 2 to the other side. So you'd have x plus 2 equals y. You agree with that? Getting y by itself? Yes? Okay, so slope of this one, it's in the form y equals mx plus b. What's the slope of that line? What's it understood? Yeah, it's understood to be a 1 here, right? So the slope is 1. It's got to be parallel to that line. What do you know about parallel lines? Same slope, right? Same slope. So it's got to go through this point, and it's got to have a slope of 1. Okay, so from that point, you're going to go up 1 to the right 1. Slope of 1, you can write that as like 1 over 1, rise over 1. So if I did it 1 over 1, that's rise over 1. So go to the right 1, go up 1. Go to the right 1, up 1. Okay, go to the right 1, up 1. Or up 1 to the right 1. Okay, and there's your line. if you go back and graph this, that's the answer. But if you go back and graph the original line, if you go back and graph this, it goes through at +2, and the slope is 1 over 1. Okay, so from that point, you go up 1 to the right 1. You go up 1 to the right 1. And you should find out that, yes, they are parallel. Okay? So this is what they're asking for, is this line right here. It's got to go through this point, and it's got to have the same slope if it's parallel. Okay? If they're perpendicular, what about the slopes of perpendicular lines? Their slopes multiply together to give you, yeah, one's got to be positive and one's got to be negative, and they multiply together to give you a -1. So like if I said the slope of one line was -3/4, the other one would be +4/3, right? They are negative reciprocals. They have to multiply together to give you -1. So if I said the slope of one line is -2/5, the other one is 5/2, okay? So parallel lines have the same slope, perpendicular lines, or parallel lines have the same slope, perpendicular lines are negative reciprocals of each other. Okay, last example. They will give you problems like this. Find the value of R so that the line, find the value of R so that the line passes through each pair of points and has the given slope. Okay, find the value of R so that each line passes through each pair of points and has the given slope. So they give you the ordered pair as an example, -1, 4, and the ordered pair 1, R. So they're not telling you the whole, they want to know what is R. And they have to give you a slope. Okay, so I'm giving you the slope. M is -3. You could do that by graphing it, but it's just as easy to do it by the formula. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Label either one of those. I'm going to label this one. Yeah, I labeled this one my x sub 1, y sub 1. I labeled this one my x sub 2, y sub 2. Now, you know what the slope is. The slope is -3. You know what the y sub 2 is R. The y sub 1 is 4. The x sub 2 is 1. The x sub 1 is -1. -3 is the same thing as -3 over 1. Okay? And I can do -3 over 1 equals R minus 4 over 2. Cross multiply to solve because it's a proportion. So when we cross, we'd have -6 equals 1 times that quantity is just R minus 4. Add 4 to both sides. And R equals -2. Okay? And again, you could check it if you put it back in here to this ordered pair. You could check it by drawing the line and doing the slope, and your slope ought to be -3 as a check. Okay? So if they're asking you anything like that, use your formula, okay, for slope, and then just substitute in. Okay? Okay.